Today we're going to try something really crazy. 23.9, close enough. These are very close to true O scale. You don't want to try this with a modern transformer. So this is based off of a real B&O caboose from 1916 up to 1938. That is not helpful. Now it is truth or consequences time. Part of the circuit is running through this wire arm here. Very simple but effective animation for the layout. Hello again, this is Mike with Toy Train Tips and Tricks. And this video, we're doing kind of a follow-up on a previous video where I talked about the basics of using 3D printers for the layout. And so I'm just going to give a little more information on things that I've already made for the layout, how the process works, and potential ideas for how you can use this technology on your layout. Now, I am by no means an expert. I have been 3D printing now for about 31 days since I put my printer together, and you see that I've already done a collection of things for the layout in addition to toys for the kids, things for around the house, tool organizers. My printer has been pretty much going like 24/7 since I first set it up. There is a lot to learn, but it has gone a lot faster than I anticipated and a lot easier than I anticipated. So I began with a very basic, good but basic printer because I didn't want to invest a lot of money in something that the technology was going to be over my head. And what I found is, I'm catching on rather quickly. So let's take you through some of the things that I have here, how the process works, and then how it could be applied for different things on your layout. So the first thing, when you first get your printer, you need files to print. You need designs. These can be done in lots of different CAD softwares. There are some good free CAD softwares like Tinkercad, SketchUp, Blender, Fusion 360, although that one is only free for a while and then it's quite expensive, but it's quite good. I understand, I haven't used it. But those are just some of the popular softwares that are used for CAD. Some are free, some are not so free. But when you first get started in this, you're probably not going to be designing your own models. You'll be probably printing at first things that have been designed by other people. So where do you get those files? Well, with the exception of this one, ooh, there we go. All of these other items I have found on a site called Thingiverse, thingiverse.com. And it's probably the largest repository of free 3D designs. Lots of people design lots of things for their own projects, and they decide, hey, maybe somebody else out there can use this. They put it on Thingiverse or a couple of other different sites, and you can go on there, you can download them for free. If you really like it, there's an option where you can tip the designer if they've got that option enabled and a PayPal account. And you can send them a few bucks, thanks for the design on that, buy a cup of coffee. But other than that, it's free to use and free to download. So you take these CAD files, whether you design it yourself or you get it on Thingiverse or My Mini Factory or some of these other programs. There's another piece of software that you need, and that is the software that takes the CAD design and tells your printer how to make it. That program is called a slicer. Now, most printers come with their own slicing programs, or you can use third-party ones. And again, many of these are free to use. My printer came with its own, but the software that came with my printer was actually based on that of another free program called Cura. And Cura is probably the most popular slicer program. It has a lot of really cool features that your basic one that comes with your printer doesn't have. You can do lots of things with it, and it's pretty easy to use. So you get your CAD design, you get your slicer, and then the slicer creates what's called a G code, and that tells the printer how to actually make the design. Where the print head goes, how much it's putting down, how many layers and where, and all of that stuff. So that's the basics of what happens. So what can you do with this? Well, let me give you an example. This is a neat little design I found on Thingiverse this is an HO scale building. If I print the whole thing out, it is, front wall, back wall, side walls, roof, window and door details and things like that. I printed out just the front face here because, for one thing, I'm short of space. I don't have a lot of room for full-size buildings. I'm going to be using a lot of just building facades on a backdrop. So this one is HO. Well, HO is a little too small for me unless I put it way, 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 way in the back. But what I can do, and what I did do, was I took this design, and when I put it in my slicer, when I put it in Cura, there's an option on there. You can duplicate, you can change the scale, and that's what I did. I changed the scale, and I boosted it up, and I printed out in S scale, 1/64th. And you can see here the formula for converting an HO scale design to an S scale design. And you see, even in blowing it up, the details are all still really good. We've got, let me get better light on it. Here's the HO scale version, and you see the brick detail and such. And here's the S scale version, and you still get all those nice little brick details and the windows and all of that. It's just bigger. So you're not limited to finding things in one particular scale. You can take HO scale items, convert them to S scale or O scale, G scale, and you can convert back and forth. Here's another example. These are some HO scale baggage carts that I printed out. These are set up as full O scale because I'm going to put these on my Lionel passenger platform. Now, if I was printing these out and I was going to use them on, say, the Plasticville Union Station, which is actually not even S scale, it's even smaller than that, just with bigger windows and doors, to put a full O scale baggage cart on that platform would look totally ridiculous. So I would then scale it probably for S scale, and actually I will print out a batch of these in S scale. I've got the original design in HO, and I just use the math formula and change it to O or S, or even something in between. If you wanted, there's all kinds of things you can do with forced perspective. Say, for example, you have a light post that you like that light post. Or we can even go with this baggage cart. I like this baggage cart, but in some circumstances I want it in O. Other circumstances, other places on the layout, I might want it in S. I could take a park bench. I like the design. Well, in some parts of the layout, being right next to the tracks, I want it in full O scale. Other parts, I want it closer to the background. I want it smaller, and I can adjust the scale on that and print it smaller or bigger, and change the percentages and print it up the way I want. You can also take these designs and modify them. This one, for example, I didn't do this, but what I could easily do is, you see the blank spot up here in the top. I could have taken this, instead of going straight to the slicer, I could have put this back into a CAD program and added, say, a date across the top, 1898 or whatever, and had that print in that space there, or put a name in there. This was the Jones building, and it could say Jones or whatever. Whatever you want to put there. I didn't, but that's another option. Now, there's another type of design program besides these, are what we call STL files, stereolithography, for your printer. There's another type of CAD design. It's actually called SCAD or SCAD. And these programs, this is an example, and the SCADs are neat because it's basically set up as a template, and you can change the features on the template. This is a program I found again on Thingiverse, and there's a link to this in the comments, or sorry, in the description. This was actually set up as an N-scale modular building, and it uses SCAD so that you can use a program, again, a free program called OpenSCAD, and you can put it in there and you can change the features. All of these basic things are like in a spreadsheet, to put it simply, and I can change the options. I could say I want a building that has 4 windows across, 2 stories tall, without a brick pattern, without this roof, and with a double door here in the middle, and it would print that. So you can change how high, how wide, how many windows, the shape of the arches, whether it has bricks, the size of the bricks. All of these things are interchangeable. And again, this was designed for N scale. So again, I blew this up from N scale to roughly S scale. I was guessing at the number. It looks like I got it a little bit bigger than S, but it's not quite O. I was kind of guessing at a number. Now I know the exact number, as you see here in the chart over here. Boom. Okay. So with these OpenSCAD, with these SCAD programs, these are customizable. You can change them around. So from that one program, I could get hundreds of different building designs just by changing the configuration of the doors, the windows, the stories, the height, the width, and so forth. So those are very usable. Now, Thingiverse itself on these programs has a customizer. It virtually never works. So instead, you'll want to download the SCAD file and put it into the program OpenSCAD. Once you get the configuration the way you want, you then turn that into an STL file and print it off that way. Okay, so I can modify the options, I can modify the size, and I can create my own designs, as I did with my coupler here. I used a very simple CAD program, and free, called Tinkercad. Tinkercad is probably the most popular CAD program out there. This is used by school kids around the world, from elementary school to college to professionals. You can do all kinds of things. It's very simple, very intuitive, and very easy to use, and you can make most things with it. Now, some of the more complex designs, if you're doing intermeshing gears and things like that, you can do it in Tinkercad, but you're probably better off using a more complex program like Fusion 360 or something like that. If you're doing more straight buildings, SketchUp seems to work really well. I've played around with that. I haven't printed anything from it yet, but it looks pretty easy to build buildings using SketchUp to a pretty accurate scale. So you can use stock designs that you find on the internet for free, or you can purchase some if you really want to. You can modify them, the size, sometimes the options, the shapes. You can add details, you can subtract details, or you can create your own. So from all of that, there are really limitless possibilities to how you can use a 3D printer on your model railroad. So like I said, I've used mine everything from doing this to tool organizers. All of these, you see the different colors I've printed in, and there's lots of things you can do with it. Lots of different options as far as the material that you use, the filament. These are all done in PLA because it is cheap and easy and pretty durable. But there are lots of exotic filaments coming out every day, including some that are impregnated with wood chips that give a wood look, even some that look like stone, and now even more with iron or stainless steel, which someday I'm going to get around to prototyping and seeing if I can make some replacement Lionel wheels with a metal filament and see how that works. Not quite there yet. I've got other things to print. The hardest thing about 3D printing, what I found, to quote Tom Petty, the waiting is the hardest part. I have about 3 dozen designs that I want to print off, and there's only so many things I can do on the printer at once. This particular building, to make this design, it took about 7 hours to print. So I did that overnight. So it gives you an idea. I did these both at the same time. It took about an hour and a half to do the 2 of them. So, you find some really neat designs, but it's a matter of lining up what's the most important thing to do on the printer next. But the nice thing is, once you get it started, you make sure that it's printing well. You can pretty much let it go on its own and just check in on it sporadically to make sure that nothing has failed catastrophically, which can sometimes happen, but I've had really good luck and very few failed prints. So there you go. I hope this answers some questions. There were a lot of comments and questions that came in from the last video I made about these buildings. But just to see what's available, go into Thingiverse and, search on model railroad or buildings and structures. See what's available out there to work with. There's quite a bit. It may not all be O or Lionel compatible as is, but you can scale it using the charts here that I have put here in this video. And you can use those formulas to change these designs around, because there's lots of stuff available in HO, in N, in G, and it's just a matter of making it fit. The biggest limitation is fitting it to the bed size that you have on your printer. So I couldn't make this a 4-story building. I would have been out of room. But 3 stories fits, so I made it 3 stories. There are things you can do to cut the designs in half and then glue them together if it's too big. For a single piece print, this is about as tall as I can get before I was running off the edge of my bed. Different printers, different designs, different sizes of beds. Okay, so again, I hope this answers more questions than it raises. And, feel free to, to comment in and ask questions in the description section. But like it, share it, subscribe, tell your friends, tell your neighbors. Until then, keep the trains running and, make some stuff if you can. And we'll see you next time on Toy Train Tips and Tricks.